Now let's take a look at Larry's method. Um, some of you might recognize this. This is called the lattice method. If I can write here, lattice, 2 T's there. And what I want you to notice is that some of these methods help to develop conceptual understanding about place value, the numbers, the digits, and multiplication as this idea of equal groups. So whether that's decomposing by place value or using the distributive property, or even in Earl's method, the last one, where he's thinking about this doubling idea and then gathering the number of groups that he needs. The lattice method is helps to simplify some of the calculations or the computations, but it doesn't really help to develop any conceptual understanding. So I want you to be able to recognize these different methods, but also to evaluate them, right? And so that's part of what's happening here. And so if you are familiar with this, which I know some schools have taught this, you start with creating this kind of large box. And just like as Larry has done up here, you write each of the digits, right? Each of the numerals in each of the digits alongside, and then create kind of like a grid. And then as you write the multiplication, and I think you can kind of start anywhere, but just like with kind of the distributive property and the partial products, in the open array, now we see how we can multiply these numbers. So here we get 4 times 1, and we write it on the inside, 4 times 3, and 4 times 8 is 32. And you notice how I'm recording the digits, because that matters when we're talking about this method. And I'm pretty sure maybe some people do the lines first to go through, so that way can keep the digits kind of in order. And you see that like the tens digit goes on the top, and then the ones digit goes on the bottom. And it's always just up to 2 digits because it's single digits being multiplied. So again, 4 times 1, you put the 0, then the 4 times 3, 12, and then 4 times 8 is our 32. And then 2 times 1 is 2, 2 times 3 is 6, and 2 times 8 is 16. And now what I want you to see, and maybe I'll just try like yellow, is that we add along these diagonals. And I'll kind of do like every other one. And then that gives us our product along this outside edge, and that's where this arrow is coming from. So this is 0, and then we add them. 0 plus 2 plus 0, 0 plus 4 plus 1 plus 1, plus 6 plus 1, right? So you're going to need 10, 11, 12. Actually, I think we're supposed to start down here, and then that way you can regroup. 2, 5, 6, 7, 10, 15, 16, and then that comes up here. And now we had this as 10, 11, 12, 13. 13, the 1 goes up here, and then this would be a 3. So you add it this way, right? We added going this way, so that way we could regroup. And then the number, the total, the product is read in this fashion here. So it's 33672, or 33,672. And so you see it's a lot of steps, and so that's what I mean by it doesn't really build any conceptual understanding. Each step isn't that difficult because it breaks down even very large numbers, right? 244 times 138 into basically single digit multiplication. So that's where some people really like this algorithm, right? And again, an algorithm is just a set of steps. So once you understand the steps, it's relatively easy to complete them, because now we're just adding or multiplying single digit numbers by single digit numbers, right? because we're viewing each of the digits individually, and then we just add up along the diagonals. So the steps are relatively easy, but I want you to see how if you miss a step or do a step in the wrong order, right? Like how I started adding, like I knew I needed to add, but I forgot, like, oh no, I don't start up here. I need to start, right? You need to add, this way, right? Start down here and add throughout the diagonals that way. If you put a numeral, right, put any of these symbols in the wrong spot in, if you either forget a 0 or misplace the place value, it's really easy to kind of mess up this method, right? Unless you do it perfect, because there's a lot going on, right? By breaking it down and simplifying the calculations into this single digit multiplication, then in order to keep all of the digits in order, right, in the correct place, it's becomes a little cumbersome and complicated. So while this helps, some people like it, it doesn't develop any conceptual understanding of multiplication. And really what I want to challenge you with is, how in the world does it work? Why, if you look here, like, we'll look kind of down this row, or, this diagonal, it's not a column or a row, right? And we see this 3 is in the tens place, but these 2s are here in the ones place. Why are we adding some tens and some ones together? What's going on here? And likewise, right, why do we have to make these diagonals? Because now all the place values seem, right, 4's 1, 4 and the 2 and the 6 in this diagonal are all in the ones, but this 1 and this 3 are in the tens place. When we did that multiplication in that little box, in that little cell. So I want you to think, like, how in the world does it work? Why does it work? And see if you can answer those pieces. Sorry, not those pieces, those questions, right? See if you can answer those. And if you can, awesome. And if you can't, that's equally awesome. Like, that's not really the point of this. I wanted to show you how it works. And I want to challenge you to figure out why, because with this one, this method not developing any conceptual understanding, I will probably try to discourage you from using it.